Analytical thinking starts from handling different business big requirements and have a solid understanding of the different analysis and analysis lifecycle, as well as identify different business analysis and when to use each one of them. That's what I will cover in this video. How to become an analytical thinker and handling business big requirements. Make sure to like, subscribe, comment, and share for engagement, and let's get started. Imagine you are working as data scientist or data analyst in Uber, and your manager gives you a business requirement in how to increase the user's rides in a specific location. This business big requirement depends on the riders and drivers side. As a scientist, you need to first start with why funnel. Set a specific questions and start from why to help you define the business objective and the business questions. That can help you with the analysis and help you to get to the right answer for this question. And the next slides are just my approach to help you navigate this question. So I can start by saying that I want to increase the number of rides on the locations. That's exactly the requirement. Then I need to ask myself why I will do that. To, for example, decrease average empty miles. So any Uber ride or any ride using applications such as Uber or Bolt, etc. First, the rider make a request. Then the driver receives this request. And the driver needs to move to the rider pickup point. These miles and time are called empty miles because they are not compensatable. We need to decrease the average empty miles. This one approach or path you can think about. Another one is to increase the driver's acceptance rate. And this one works hand in hand to decrease average empty miles because when the driver have small or near requests, his acceptance rate or he is probably more into accept the trips. So he will have a more completed trips, which is a good sign for the driver's point. And from the rider's point is to get a nearby driver that also decrease the waiting time. We have the driver's cancellation rate. Also, this one is quite relatable to the last two pillars. So accepting more trips means decrease the cancellation rate from the driver perspective. And that leads us to decrease churning rate. And this is a very solid KPI or metric to follow. It's pretty costly to make driver acquisition or to find the new drivers, import new drivers to using the service because they need to sort the documents and ensure no criminal records, etc. So it's quite costly and it can take several weeks to import new drivers to the app. That's why decrease the churning rate from the driver's perspective is very good sign. Also to decrease that can positively help in decreasing the riders cancellation rate and riders churning rate because they now getting more opportunities and small short time, etc. So this is really good situation. We started from a big requirements and we moved in different directions, and that can help our cause to address the business question and drive more valuable insights and work on different KPIs, so more opportunities to the company. Then we have data analysis lifecycle. I like to have a checklist or a map when it comes to data analysis lifecycle. But before we start with this one, I forgot to mention one important thing when it comes to increasing the acceptance rate. Acceptance rate can be a bit challenging path to track because it depends on riders' ratings, drivers' personal preferences for certain trips. As driver might want to receive all, make all his trips inside the city. He doesn't want to move to another city. Okay. Another driver might prefer to travel to other places because long trips means profitable trips, more money. and maybe another driver prefer the airport trips. So it really acceptance rate can be a bit tricky here, but the other pillars or the other metrics are quite approachable. Then moving on with data analysis lifecycle. So what we want here, we're starting by defining the business goals. What I mean by that is what do we want to affect? Do you want to improve the user experience, increase loyalty, decrease the churning, etc.? Then we have defined business KPIs and metrics. This comes from asking realistic business actionable questions. Those questions with the right AI model and interpretation can lead to actionable decisions by stakeholders. I dedicate a whole video about these two attributes, how to articulate business questions and business KPIs. Link in the description because I find these 2 points are really important and crucial in any business case you handle. So I want to highlight that my point of achieving all that is to set a baseline that despite the vague requirements that require to create a map with the business questions, KPIs, potent variables, analysis you look for to use, and flexible mind to notice the hidden patterns. Then moving on to the next point, the select data tables, build data pipeline, and data cleaning and wrangling. This is really crucial in any analysis you handle. So we started with defining how to select data tables. The data will be used to address the business goals. You spend time to fathom the data columns, if there are duplicate columns between them, how to merge different tables. Then we have construct data pipelines. So in this step, you use like a bunch of SQL queries and data warehouse, ETL and ELT, etc. to design a solid data pipeline. Then we have data cleaning and wrangling, handling duplicates, nulls, missing values, outliers, data format, if the data needs to be normalized, etc. It's a crucial step. You take a lot of time doing this data cleaning and wrangling. Have the next number 6, exploratory data analysis, EDA, and select analysis types. So when it comes to that, EDA, it's like data distributions, correlations, run different statistical analysis like mean, median, mood, checking skewness of the data, etc. And then we have the select analysis types. It is defined based on the business goals. If the case is predictive analysis or it's descriptive analysis or causal inference, etc. And I will cover how to select analysis types in more details in the next slides. Don't worry about it. Next, we have validate. First, we have set baseline or a threshold. Then we have validate and interpret results and articulate business decisions. When it comes to setting baseline or a threshold to support business outputs, just to ensure that the analysis is relevant to the business values. For an example, your initial analysis can give average waiting time before starting the trip equal to 2 hours. This number cannot be a baseline because it can't be realistic. It can't be waiting time by a rider. He waits 2 hours before starting a trip. So there is like a few values when the driver waits for the rider before starting the trip for more than like 30 minutes or so. This can also not be realistic. So when it comes to machine learning or AI model, not every value it's like executed or not every value is generated can be realistic. So we need to have a baseline, a business baseline before saying like, aha, the AI model or the analysis is generating correct answers. Because sometimes outliers and anomalies can affect our model. Setting a baseline is important. And the best naive case here and the best thing you can do is to ask for what are the usual or what is the sweet spot? Like here, we want to understand how to decrease the churning rate, for example. What is the historical churning rates in the past few quarters? This can help us because if the churning rate in the past few quarters were on average or in a range between 10 and 14, if your model generates like 30%, this is incorrect, affecting our model negatively, and you need to understand why. So that's what I mean by setting a baseline. Then we have validate and interpret results, and there are many ways to do so. You can use like SHAP for an example method, or interpret or validate these values with respect to the previous historical data, the previous quarters. Maybe you can validate it with your colleague or your senior analyst, etc. There are many ways to validate the results, ensure that they are correct. And finally, how to articulate and make business decisions. This can be achieved in numerous ways through storytelling or Tableau dashboards or recommendations or even Google Slides. Tell the story and show them the main features of your analysis. Can be valid. Then moving on to data analysis flowchart. I came across this beautiful blog. What is the question? I will add the link down below. And data analysis flowchart is amazing. Despite the blog was generated in 2016 or 2015, it's still relevant to the business cases we have today. So we're starting by the first line, not a data analysis. If the answer is no, like, did you summarize the data? You did it, not a data analysis. If yes, did you report the summarize without interpretation? Yes, then it is descriptive analysis. No, did you quantify whether your discoveries are likable to hold in a new sample? No, this is exploratory analysis. If yes, move on to another question. Are you trying to figure out how changing the average of one measurement affects another? No. Are you trying to predict measurements for individuals? No, then it's inferential. Yes, it is predictive. Then back to the right side, is the effect you are looking for an average effect or a deterministic effect? On average, causal, deterministic, mechanistic. Okay, and I want to make a modification, tiny modification here, is that between inferential and causal, there is more solid approach is causal inferential analysis, and I will cover this one also in the last slide. And mechanistic, we don't use it usually. It's quite rare, and I haven't included in this video at all. But if you want more information about it, you can comment down below, and I'm happy to investigate it further. So we start with EDA, or Exploratory Data Analysis, a critical part in any AI model. The baseline is set to understand the patterns, limitations, and quality of the data at hand. And there are numerous ways to do inside the EDA. We started with like detecting missing values, duplicates, outliers, skewness, performing statistical calculations such as mean, median, standard deviation. Standard deviation can be also described as volatility of the analysis, okay? And range. Range is like subtracting maximum value minus minimum value is the range. Identify trends, seasonality effects. This one is related to time series analysis and moving average, etc. Then we have the data set scaled or need normalization. This one is also a good feature to track in EDA. And we go through this step to understand the data table or tables, check the data quality, highlight the main numeric features before feature engineering, then building the AI model. I came across this blog, Exploratory Data Analysis, EDA versus Descriptive Analysis. I will add this blog in the description. It's amazing and has a lot of good ideas. Feel free to check it out. In the predictive data analysis, we have the variables and target response. Target response is the one we want to predict. And we use the variables such as education, age, years of experience, gender, location to predict the data science annual salary. Okay. And there are other variables we can consider, such as marital status. And predictive data analysis only shows that you can predict one variable from another. It's not necessary explain how that choice of prediction works. To describe confounding variable is imagine you have an experiment. You want to know if lighters and lungs cancer is quite related or not. Someone who have a lighter in his car and close to him always is necessary have a lung cancer or not. So confounding variable will be smoking. If you omitted the confounding variable, then you might think that, yeah, lighter correlated or directly related to the lungs cancer, which is not correct. What is actually more significant, a higher chance of getting a lungs cancer if the individual is smoking. What is correct is that smoking, if the individual is smoking, there is higher significant chance that he might have also lungs cancer. And smoking is the confounding variable. Then we have the causal and inferential data analysis. So causal data analysis, it focuses on understanding the underlying cause and effect relationships, like ice creams and shark bites. More sales in ice cream can lead to more shark bites, which is quite not relatable, but it happens at the same time. And the confounding variable here is that the summer. In summer, there are more chances of shark bites. And in summer, there increase in selling ice cream. And using causal data analysis alone, it's more like intuition without a solid methods or statistical methods yet. And common method is randomized controlled trials, RCTs. On the other hand, we have inferential data analysis, that drawing conclusions about population from a sample. And inferential analysis implements various of statistical techniques, such as t-test, ANOVA, Bayesian inference, hypothesis testing. And inferential data analysis address the question, what does the data tell us about the population? Combining these two together give us a solid, powerful technique called causal inference analysis. So causal inference analysis, it connects two potent techniques, causal and inferential, using statistical methods to identify the cause and effect relationships between variables. The most prominent methods are randomized controlled trials, RCTs, difference in differences, and let me know in the comments if you want a video about these strategies in practice using Python or R. Then we have two characteristics associated with causal inference. The first one is confounding, after the variable bias. So variable one, then we have the confounder, then we have the target response. Carrying a lighter, smoking, lungs, cancer. And omitted the confounder, it's more like it tricks us into seeing causation where there is only correlation. And that's why we have the cliche item that causation doesn't necessarily lead to correlation. For this reason, we have this cliche phrase that describing the error in the analysis, that correlation doesn't imply causation. Then we have the counterfactual. What if scenario, the two dimensions, Doctor Strange type of thing. So if, for an example, if John took the medicine and get better, the counterfactual is what would have happened to John if he hadn't taken the medicine. And since we cannot measure the impact of two realities at the same time, counterfactual is quite challenging. And that's it for today. Thank you so much for watching my content and subscribe for more meaningful content. And I see you in the next video. Bye.